Okay, so this is the first second derivative video. I'm redoing it because I didn't like the last one. So we're going to look at the function f of x equals x to the third minus 4x. The first derivative I took, so use the power rule there. I brought the 3 in front, and then x squared minus 4. And then the second derivative is the derivative of the first derivative, which is just 6x. And so then I used Desmos and I graphed the function and the second derivative. Now what the second derivative helps you figure out is the concavity of the function. When the second derivative is negative below the x-axis, notice the function is concave down. So when the derivative is negative, the function is concave down. When the second derivative is positive, notice the function is concave up. Second derivative is positive, the function is concave up. Or when the function is concave up, the second derivative is positive. It's above the x-axis. Notice the inflection point right here. This right here is my inflection point. Notice that's where the second derivative is 0. Now you don't always get an inflection point, but you do if the concavity changes. So this is my inflection point. Sometimes I can get inflection points other ways, but one of them is if the second derivative is 0, sometimes you get an inflection point in the function. Let me write the word inflection point. Inflection point, it's where the concavity changes. Okay, this time it was concave down to concave up. Sometimes it's the other way. So those are inflection points. So the most important thing is what I typed out here. When the second derivative graph is negative, the function graph is concave right, down. And when the second derivative graph is positive, the function graph is concave up. Okay? When the second derivative is 0, there's a possible inflection point for the function. In other words, the concavity would change at the inflection point. It's not always the case, but it sometimes is. So if the second derivative is 0, that's where you will often find an inflection point. Again, not always, but sometimes. It could be just a critical point. It could be, a max or a min, depending on the first derivative graph. But just kind of keep that in mind. You're looking at those kinds of things. All right, that's it.